So last time when we were talking about foreign exchange rates and foreign exchange issues, then obviously at the beginning I mentioned that historical trend can be estimated. So let's see that if we are just letting the things go ahead, what happens. Then also Excel has this nice forecasting feature. We will see it. Then we can do this Monte Carlo based simulation, which is focusing on the GARCH model, which models the volatility of the data, and that's why we can use it for other purposes, and then we can use it for simulation. And obviously, in this case, when we are using the data itself, we are always assuming that all the information is in the price, so the market is efficient. And this is a nice expectation. Obviously, it is not, but yeah, let's have romantic assumptions. And last thing is that we have to build up a macro model. What we learned on international finance, let's test it. Is it useful or not? So that's why today I would like to download data about US dollar-euro exchange rate with high frequency, so daily. No, weekly. It will be weekly because it's easier for coding. So weekly data, and it will be also monthly data. Potentially we could use also weekly data for VAR. I never use it, so let's use it, because no, we don't have weekly inflation. That's the reason we have to go for monthly. And yeah, so zero step is to see that USD euro rate, and we don't need anything further because in this case the question is that okay, so we need the data to parametricize the model. So we need historical time series. The question is that how long should it be? Because obviously data from the last 10 years can be enough. But if we are going for even longer time periods, the problem will be that the underlying economies were changing so much that maybe it can bias the data, but what happens if I'm hitting maximum? So we can go back even earlier. So before 1997, we don't even have ECU, so I don't know what is happening here in terms of this euro exchange rate, but okay, so 20 years will be completely enough. So we are starting in 2005, and then we can see the gradual depreciation of the euro, which is really strange because the whole 2000s were about strong euros, and then it was giving away once the ECB implemented the quantitative easing monetary policies, and the spillover or spin-off effects were related to this one. So we download the first data series, and then we are going for monthly data. And in this case, we can add the additional. Then in this case, I should do the same thing. So the problem with this database is that so if I'm just switching USD, still you can see that the coding is not the same. So this one is average, this one is related to one bank, but okay, let's use these indicators. Then if I'm just saying that okay, I need CPI for euro, change annual, something like this, CPI change year to year, so this one should be used. And now I have everything. Oh, 20 years. Maybe we will cut from this one, because here the problem is that I'm training the data set with all this data from the past, and now it's from the last 10 years. It's still a problem, because here we have low inflation, a low interest rate environment, and then suddenly we have this spike here. So we have to manage this later on. So let's download this one, and after that we will create a comprehensive database from both of these. And we don't have inflation data for October and November. Come on, we have inflation data. Okay, so right now we have already missing value issues. Then let's order it from bottom to up. Noise. We can see that this is mostly. And also we should load in weekly higher frequency data set. So the easiest way should be that let's create a nice diagram about this, and of course we should just change the euro exchange rate. And after that, easiest way, that I need something to understand the trend line, so let's add the trend line. It should be a linear trend line. Let's add the equation to it. And once I did it, then we can see that, yeah, the euro is depreciating. So case closed, we can go for having a lunch or second lunch. If we are still saying that we would like to do it precisely, then in data and forecasting, it's Hungarian. Okay, so data forecasting. Wow, now they have, it's a curvy thing. Before of that it was just a flat line. Now they are developing it. Cool. What kind of settings do we have here? Oh, we have confidence interval. We have beginning of the forecast. Practically, we don't need any setup here. Yes, I understood. So here we have, so it's a big development compared to what happened in the earlier Office versions, when we just had this not so sophisticated approach. So now this is moving. Cool. So also we can do it. Again, the result is the same, so it forecasts some kind of a depreciating trend for the euros. The problem for me is that we have no idea how this was generated. So if you are starting to read the documentation behind the Excel, we can find some kind of methods, but still it's non-transparent. So okay, let's save it into our Matlab sheet, because yeah, so Excel's own forecast. It's something, just I don't like this kind of something. And also I'm moving it here. I don't want to have anything on this sheet. So, next thing. Let's open our happy Matlab. And in this case, we should see that what happens if we are hitting. So, if it would be up to Mr. Rácz Tamás, then he would fit an ARMA model on it because he likes ARMA models. I like GARCH models because GARCH models are modeling the volatility of the data. So it's not just and it's not just about the volatility, because it assumes that the change of the exchange rate will be the multiplication of this volatility and this error terms, present value. So not t minus I, but in epsilon t value. So they are multiplying them together, and this is what generates the change within the data. So we are already modeling two variables. So not just assuming that all the changes within the data will just come from the past value and some error or shock or innovation, but still we are modeling the underlying process that, okay, but this volatility is changing also in time, so it's more comprehensive. And now finally my Matlab was loading in. So I did not in the past Matlab was on the menu for this class, but since we have already entire risk management in finance class for the spring semester, I'm keeping this for that time period, because for this class Excel is more proper. So this one is just an introduction or demonstration that what we can do in this software. So obviously I should start with clear to clear all the workspace here. So in the editor we are doing the coding. We have to load in the data. So everything what is happening on the equations left side will be the output, and everything what is happening on the right side will be the function. So we need an XLS read function within a bracket. Then we have to define this. So I'm defining the name of the and what we need here. We don't need this one anymore. What we need here is we have to load in the weekly. Answer is and also we can see that so forecast with large models, and then for 0 step is loading the data. And right now its problem is that I'm inside the file. Sometimes in this case they are not able to approach it. I don't know why, but could not be activated. XLS read. Okay, that's a strange anomaly, but in this case I will do it by hand. Just the problem is that so we have to calculate always on the changes of the data. We could do logarithm, but in this case I don't want to overcomplicate Data. Oh, I should rename this one. Sorry. I don't want to overcomplicate it with logarithm because already these numbers are really small. So if we are checking them, then their changes are relatively smooth. So usually they are just fluctuating between 0.02 and minus 0.02. So we are not talking about GDP, which is measured in millions. So it's good. But still we can see that these changes can be quite abrupt sometimes. So we have extreme jumps. Sometimes the market can price in this currency really well, and sometimes their sentiment about this calculation is not that exact or not that stable. So if we are just fitting a QQ plot on this one, so the data should fit on this line because this is supposed to be normal distribution, and we can see that until we are close to the mean, so until close to 0, then it fits completely well. But once we are in the less probable environment, then this will go away. So it has much more extreme jumps in positive and negative territories than it's supposed to have. Or also I can show you the not in the plots, it's in the distribution filter up. That's still again the key problem of all risk management will be visible here soon. One second. Okay, data ret. Yes, please do it. Okay. Close. And then if we are just saying that, okay, this is the empirical distribution, so we would like just to put a normal distribution because we are always using normal distribution in finance. And the problem is that, as you can see here, it says that after this point, practically it's impossible to have any further movements. So it's not probable because it has 0 probability. And still we have this guy here, that one, and that one as well. So we have much more depreciations than it's supposed to be. And also the same thing is valid for here at the tail, which is going down to 0 here. And already we have an excessive change here as well, but also here and here. So we have more excess volatility and excess currency movement, and that's why excessive volatility than we should have in general. And also the market is way more lazier than it should be around the mean as well. So we have much more mean data than it should be in theory. So we can see that normal distribution is a good start where we are building models. That's why they built all this efficient market and option pricing and other things in the past with normal distribution in mind, because it's good enough, just not that great. But we have another class for talking about this. So to keep it in our mind, we should go for the GARCH model. So in this case, I'm using, there is a really nice guy called, or professor called Kevin Shepard. At the Oxford University, and it looks like this. But why he's famous for me, that he developed the MFE toolbox, which is not updated, so now it's not updated for more than a decade now, but it contains all the necessary functions which can be useful for us. And it's still much better than what is provided by Matlab if we are paying for the toolboxes. So You just have to download it and extract it, so it's a zip file. And after that, why it's good for us? Because we can estimate this model in a really simple manner. We have just one function for that one, which is already opened, and we can just say that, okay, I would like to have not all these, neither you. That's all what we need for estimation, and in this case epsilon is ret. We have to parameterize the POQ values. I will talk about them immediately. And of course the error type. So right now this seems to be ugly, but in case of P value, when we are going back, so we have to parameterize that how long do we would like to look back if we are thinking about the shock. So it only affects us what happened at the last week shock or 2 weeks ago and so on. Last week is completely enough. So it's last week's shock is considered. So we can play with it for a day, but it's not necessary to add more. Usually these things are not fitting well. Okay, the O value. So in GARCH, simple GARCH, we don't have any O value, so we can set it to 0. EGR GARCH is much better because in this case we can say that volatility increases if returns are increasing, so if the currency is appreciating, which is happening in case of the Swiss franc. In other cases, usually when there is appreciation, then volatility increases as well. So we can see that volatility increases when we are going only in one direction. So this is the asymmetric nature of volatility. So we will see that this is not valid for here, but because in this case we are comparing two key currencies, and somehow EGR GARCH is not preferred by the model in the most of the cases. Okay, and Q is again how long do we look back when we are thinking about past volatility's impacts. Usually this beta is around 0.8, 0.9, so it's really important what happened in the last week in terms of volatility. So how uncertain the market was about pricing the euro. But it's also 1 week, so this is volatility persistence. So last week's impact, this is completely enough to calibrate it this way, and also why it's good for us. So here the function nicely describes itself, but we could have normal distribution, which is nice, but we would like to do simulation, so we will go for the skewed T distribution, which is has higher or longer tails, and it's also asymmetric, so it's not fitting around 0. So we are going for the overkill skewed T distribution because this can be much, much better. To add more extreme jumps. So we can have a way more realistic model here. So once we are running this, then it will be executed, and after that in the parameters we can see the following things. So let's say GARCH. again, decimal, comma, decimal point, and just bringing down everything to 2 decimals. And here we can see that this is a GARCH 11, and I will zoom in to make it visible as well for you. So here we have the same model what we have here. So right now these parameters are showing us the value of alpha, the value of beta, and other things. So this first we have to start with the constant, obviously, because but the constant is usually close to 0, so nothing interesting is there. Then alpha, so the importance of last week's shock, on today's volatility. Yeah, this is usually around 10%. So all the rest is coming from the beta. The importance of last week's volatility on today's volatility. So if you remember one thing from this class or about GARCH models, that volatility persists. So if last week they were not able to price in something, then this week will be also. So you have needed a lot of long time once a volatile period ends. Or if you are in a calm, low volatility period, you can assume that it will go on, but once you have one shock, then it will accumulate into more shocks. So this is the problem of volatility, that it has these issues. And also we have 2 additional variables which are related to the student distribution. Right now we can ignore them, so I'm saying that. So these variables are nice, just they don't have much usage for today. So. Then let's see that if we are doing this one, other benefit of fitting the GARCH model is that we have standard, conditional standard deviation. Which means that this ht is variance, so we have to take the square root of this, square t, ht. But after that you will see the beauty of this one. We lost 1 day because of the differentiation, and we have to compensate with the come on, Excel. Okay, and we should have the date as a date. So now we can see that on, if you are not assuming that standard deviation is a fixed constant variable, but it has a changing nature since this model allows it, then we can be way more precise about the estimation of risk, because risk is captured through standard deviation. So we can see that this is changing from week to week and happily affecting the market or reflecting on the market. So this is when Lehman Brothers collapsed in 2008. This is some kind of a Greek crisis, I think, from 2015. This is the Eurozone crisis in 2011. This is COVID, I think. Yes, COVID lockdown. This is Putin's adventure. And yeah, and all the related crisis situations for 2022. So we have all the fun and games represented here, while if we would just fit or estimate the STD ret, so if we would just say that, oh, standard deviation is a constant number, then we would have only 0.015. So this line would be the volatility, which means that in this case, in many cases, we would absolutely underestimate the level of volatility. Sometimes we are overestimating it, but the problem is that if we are running anything like value at risk modeling, if we are running or estimating option pricing, we should use always these GARCH models. In many cases now it's a built-in feature, but that's why they are highly popular nowadays, because it's really easy to sell options in way cheaper than you're supposed to do when you are just using simple standard deviation. But now let's go back to the simulation implication of this model. So we have this other touch simulate function, which is nice. Okay, so time. You can see the rest, POQ, error type. We don't need a parametricized touch type because it's set to 2. Okay, the length. We have to look forward by 5 years. So at the end of the day, we need 5 years multiplied by 52 in terms of weeks. Parameters are parameters, POQ are there, error type is there. So what we have to do here is to do it this 100 times. So for j equals 1 to 100, then we will do this parameter fitting. Right now it would just, it would do not much because this is just creating us a line. So, but once we are adding this to the last known exchange rate, then we can see that if we are just adding further and further and further, we can create one possible scenario. And from 100 possible scenarios, we can then from 100 scenarios, we can see that which one is possible and which ones are the extreme levels. So that's why it can be a good tool. So what do we need here is to set the sim data 1 will be the last known value of the data. Yeah, so if we have a bracket behind the variable, it means that this is the row and this is the column. So first row, first column will be defined by the data's last known row. So what we measured last time, this exchange rate from last Friday, and plus simulate data 1. Yep, and here we have to reflect that this is just the J's number of simulations. So okay, and maybe we should also define that equals. So we should keep this here. So this is the length. Simulation, because after that we can change it or expand it or do something with it. Yep, so this will be the first simulated data point. Okay, now you can understand that I'm talking. Yes, so this is one possibility. But after that, we can build up second for cycle. So in this case, for I equals 2 till t. So all the simulated data lengths will be used up here, and just saying that the ventilator is running so fast here, but right now this computer is doing nothing at all, so it's idle. And now the Matlab is running from here, so this one is just a screen and it's running at high speed with the ventilator, but okay, let's try to keep cool. So we are just taking the last known simulated data, adding the current value of the sim data, and just adding it further and further until we are reaching its end. So let's see that. 20, sorry. There you have it. Yes? Now we will have a whole class next semester. So right now this is just a demonstration that if we have this, then how can we work with this one? Because I think for Excel we don't have anything like this. So we don't have GARCH function. If we would have GARCH function in Excel, then we could do it also by hand, but I think it's faster. So one possibility from the infinite ones is that the euro will have this sudden appreciation, something nice happens and then it will go up within 5 years. It's obviously nothing more than wishful thinking right now, but now if we are testing it for 100 times, then we can have more robust results. So this is the Monte Carlo solution for this one, because in this case we are just plotting out the same data. So if you see any paper or research paper or forecast on anything where you have such results that you have a lot of different possibilities, these are always similar to what we did here. So they have an underlying theoretical model, they are just filling up with parameters, then running it multiple times for a set length, and after that we can see that what is possible here, or what can be expected. Obviously the expected value will be around the average of these lines, so we can just split it for each year. So after 52 weeks, and then 104 weeks, and so on, to have all the results for each years. And then we will go for the average or mode to get the expected value, and also we can collect the extremes, extreme 5% probable and also other extreme 5% probable data, and after that we can see that a range of possibilities in terms of exchange rates. Obviously this is changing from simulation to simulation, so if I'm re-estimating it, then oops, we will have different lines. This guy is going up. So at least we don't have negative values, because that one would be crazy, but okay, let's say that this one is enough. So you can ask the question that, yes, but what would happen if I'm using normal distribution? The result would be, and I will show you immediately, that we have way narrower volatility. So right now we can be everywhere between 0.6 and 1.6. So 60 euro cents is the range, we can say. If I'm going down from skewed into normal, then the problem will be that this will be more conservative. This is not the case, but anyway, so usually when I have more luck than this one, then we have higher chance for higher volatility. But instead of just looking at the spaghetti, let's see that what happens if we are separating the data set and collecting the expected and the extreme scenarios. Because this is my favorite part, because we don't have just one value, but also we can see the worst case scenario and the best case scenario. So in this case, we need percentile, no, and what is the name? Quantile, sorry. Yeah. So we need the quantile. For the same data, and in this case we can say that okay, I need the 0.05, I need the mean 25, so this one is the extreme. Plus or minus, I'm always confusing them, but this one is the expected. And this one is the other extreme. And still we have to look forward by 5 years, so we can see that for J. How do you look like? Okay, so we have to go this way, so in this case it's I, 1 till 5. So we need 5 years. And we can see that, okay, I multiply by 52 and all the columns. No, sorry, and also I have to define it. It's more elegant this way or that way. Yeah, no. First column, ice row. This is much better. And also, I should not forget to close down the end of the rows because this is nicer. And for formatting, I should use tabulator here, and now it looks elegant. And now this is what we... Okay, this is not nice. So now this is what we have here. If I'm copying this to our Excel sheet, so this is the expected, this is the depreciation, this is the appreciation. For the currency in the first, second, third, fourth, and fifth year. So now we can say that or let's say scenarios. So now we can see and we can plan our scenarios during the next seminars, because in this case we have exchange rates. So we can test that if we are just fitting them instead of the current 1-1 exchange rate, then what happens here with the profitability, what happens here with the profitability. Since all your, in my case, only my revenues are affected, obviously depreciation will be much better on the other one. So yeah. So that was the GARCH solution, and still I have half an hour for okay, not here. So there is the script as well, so nothing will be lost. And now this is the beauty part. So I have to create this model here, and in this case obviously what we need here is the exchange rate, so we need this one. But still we should create here the sovereign premium, and also inflation difference. In this case, if you are doing this estimation and applying this model, this will be the international Fisher rule, what you learned already on international finance. If sovereign premium is negative compared to the Eurozone, so in the US they have higher interest rates, then it means that the US dollar should appreciate. If it's negative, then the euro should, in this setup, the euro should depreciate. If it's positive, then the euro should appreciate. The same thing is for inflation. If we have higher inflation in the Eurozone than in the US, then our currency should depreciate. So let's keep it here. And after that we can build up our var output. So here we have these three variables. The question is that we should need also additional dummy variables which are representing the recessions, at least. So yeah, we could do without of them, but come on, that would be terrible. So business cycle clock made by the European Commission provides us the necessary data. The problem is that it's on quarterly time periods, so available data. But luckily, since 2014, we don't have much issues here. So only the second quarter of 2019. This is what we have. So dummy for recession. So usually it's 0. But second quarter of 2019, so already before the COVID, we have built up in terms of, that was slow growth, and then once COVID arrived, it was jumping to recession. But until the second quarter of 2020, we have this official recession. Also second quarter itself. Ends here. Then the next thing, since 2022 fourth quarter, we have another slow growth period, which is, I think sooner or later it will jump to a recession if nothing happens. So yeah, and after that still we have to define that what can be expected. So let's look forward. Can be, if I'm setting it to date, can Excel cooperate with us? Yes. So we have to create, or we rather have to set the forecasting range. So let's go only until this level. And at the same time, exogenous shocks must be defined as well. So dummy variables must be defined. So this guy here, let's give it a gray color. We have to set it. Let's be optimistic and let's say that, okay, what would happen if we have all this time period as a recession? Nice. So, okay, we can save this. And after that, we can build our own model. When we are building this model, then we should have to consider it always that what is the direction of the shocks. So shocks are coming from these variables. And shocks will affect these variables. Response. And obviously they will affect themselves. So they will set to 1. But after that we can say that this is alpha 1, 1, this is alpha 1, 2, alpha 2, 2. And these are assumed to be 0. So we have a hierarchy between the different shocks. So that's why it's really important that what is the loading order here, because obviously inflation will determine the exchange rates. Sorry, exchange rates. Inflation will determine not just the exchange rate but also the interest rates, because we have inflation targeting monetary policies. So we have to say that no, the right order for loading all these things will be that inflation is the first one and the second is sovereign premium. So now we just have to load this in, and in this case I'm using another fancy software, Eviews 14, since it was launched this July, and I had to purchase it for scientific purposes. So that's why we are using it today, because it's also free for students, so you can get a free student license. This was not free. That's what it is. I would be so happy if it would be free for me, but I had to purchase already the 11th, the 13th, now the 14th version, because the university could purchase it for me just when I need this. No, please. I need it immediately, so that's why I can't wait until... What is this? I mean... Blah 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 blah. Did I open the wrong one? Sovereign. Somehow my variables are missing. Okay, let's save it again, let's load it again. Nope. Maybe I was not paying attention enough. Sometimes you are not able to see it, but why? Or somehow. Okay, so what happens if I'm moving it here? That's a new bug. Mostly. But even if I was saving it, and it's blind to it. Let's close down Excel. Oh, now it's easy. Okay, so it's an Excel and all the other software bug. So cool when they are killing each other. Okay, not to link it. Then open again the Excel. Okay, so we have the sovereign premium, we have the inflation difference, and we have the dummy variable here. Okay, so at first we have to see that how many data points do we have here, because we will need a training set to train the model, and also we need a test set for testing the model. Usually people are using 80% of the data for training, remaining 20% for testing it. But since market is so crazy and we have so many shocks, usually what we can see here that 90% of the data is used up for training and the remaining 10% is for testing, because in this case the new data will be still in the model. So that's the core problem here. And it means that how long is this? Uh, 120, sorry, 190. No. So 107 data points must be added, and the remaining 12 will be used up for testing the accuracy of the model. And still we are wasting a whole year with this. So that's the key problem. If you are losing 1 year, it means that no. Yes. Okay, let's save it. Because in this case the rest of the data set, so everything after this data point, so 10 until today, will be used as an input. And also I was able to see one mistake, that inflation difference was 0. Yes, it's not 0, it should be missing data. Oh, it must be in edit mode. Come on, and edit it. Okay. Now, once we solve this, because in this case the regression will try to balance this out, now we have to see that what should be the loading order. So and the just variables for this model will be these two. the legs. So we are always building models which are representing 1 year. That's the key in forecasting. So we are starting here, and then we will check the diagnostics and exogenous will be the recession. So when we settled all these things, then we just have to say that oh my god, I was talking so much I forget to. We have euros here. So this should be exogenous, a nice thing, but yeah, so US dollar euro. Okay, estimate var model, then we have to add the variables, we have the recession, and we have 12 years. And still there is one issue that when we are estimating any kind of regression, then we should add always differentials. So the change will matter, because otherwise if we are not doing this, then the whole recession, come on. So the whole regression will be biased by the lack of stationarity, which is bad. We have specialized models for these cases, but I don't want to overcomplicate everything even further. So in this case, we should check the residuals. Do we have additional information in the data or not? No, we don't. So we need this diagnostics. So do we have additional information in the residual? So if these probabilities are smaller than 0.05, then it means that we have additional information, and in this case, the whole model will be absolutely biased by this information. Luckily, we don't have, so we can say that this is green. So no, they are not biased, and that's why we have to add past values. So if we would have any bias here, then we can increasing the leg number further and further. So that's why we have to set it to 11, because obviously exchange rates, interest rates, and even inflation has they have this memory. But you learned at Tamás, so they are following this ARMA or autoregressive processes. So that's why we have to test it before doing anything. But we solve this. Also, we should avoid to have any extreme jumps or outliers within the data set, so it must be normal distributed. I mean the residuals. So when I was learning this forecasting from paper from the French National Bank, they were saying that if you are analyzing just historical data set, then this lack of autocorrelation is the primary objective. In this case, it doesn't matter that what we have in the normal distribution and the residuals, whatever. But if you are forecasting, this will be our primary diagnostics. So in this case, it doesn't matter what is happening here. Right now, both of them are perfect. But if we have to choose, then in case of forecasting, we have to have this one. So until we don't have normal distributed residuals, we can't run any forecast, because this will be also biased. And right now, all of them are behaving nicely. Okay, the second variable, which was sovereign spread, is not behaving nicely, but we can control it until we are adding additional dummy variables which are representing structural shocks, regime changes in the monetary policy, and all these things. And we can balance this out, but right now this looks nicely, so we can. So diagnostics are good, so let's see the results. Impulse response of the EUR/USD itself only. Let's look forward by 2 years, not accumulative. Let's go only for the narrow confidence interval, and this is nice. And what we can see here, nothing at all. So this is only significant if both the line, the median line, and also the confidence intervals are positive, or both of them should be negative. And what we can see here is this scissor-like shape. So here it's significant, negatively, positively, negatively, positively. So there is a back and forth feedback, but I'm not satisfied with this one. So let's go for the structural long-term model, because usually this has a better performance. No, accumulative results. And structural decomposition. Yeah, now it's cool. So what we can have here is that so if inflation is bigger in the Eurozone compared to the United States, then the euro will start to depreciate. So this is what we have here. So for a year ahead, if we have this terrible inflation data, then the euro will have also a tendency to depreciate. So it's textbook. This one is not. So it means that if the sovereign premium is positive, then the euro should depreciate, which is absolutely counterintuitive. So this one would require at least some special attention here, because this is not how it should be. It should be positive. So this is only negative in emerging economies, like we can measure it for Hungary, for Poland, so for everybody, but for these key currencies, this is not a good result. But okay, for today, we can say that it's good enough. So results, they are. Also, we can see the relevance of the variables by checking the variance decomposition. I should go copy this and then paste it here, and then see. So in this case, variance decomposition highlights the of each variable. So while impulse response functions are showing us the sign of the impact, so it's negative, in this case it highlights the importance. So we can see the sovereign premium is quite a meh variable here, so it defines only 2% in the first month, then okay, it increases to 11% after a year, but here what we can see, inflation difference matters a lot. So this is what is relevant. So ERF, sign of the impact, positive or negative. Then finally we can go for forecasting, because that's why we are sitting here today. So SOF, and this is what is not provided by the Eviews the free Gretel can do it automatically, but somehow we have to do it by our hands, which is terrible. Okay, I should copy it before I'm making a mistake, and I have to type it manually again. So forecasting range. Range. Dynamic. Oh, we need confidence interval. And then let's go ahead and hopefully it will not fail. Okay, so if we have to think about inflation, then we can say that this is absolutely not a significant result because confidence interval is in negative, one side is in positive level, and altogether it says nothing. In terms of sovereign premium, at least for long run, we can see that it will be Eurozones should pay more. But in terms of currency, we can see that some slight depreciation can be could be assumed. So if you are just copy it, so if you meet with any kind of forecast about currencies, inflation, anything like this, then such a model is used in the background. So, so since the 1980s, since the born of war models, central bankers, investment funds, and everybody uses these models for doing such forecasts. So this is highly general, and that's why we are learning these things at international finance class, because after that they will be the basis of such forecasts. So now we can ask the question that is this thing better than this one? Yes, because it contains real understanding of different macro variables and their relation to each other. So it's supposed to be better than just fitting some kind of an unknown process and then hoping for the best, or just putting a stupid line on this, or just running until whole model until we have this kind of results. So this one is much more scientifically based, even if we can see that not much is happening. So this is fluctuating around 1-to-1 ratio, which was already in the case study. So in this case, it suggests us that we should do nothing at all when we are doing the estimation. So yes, so that's all. We have also not much about forecasting dynamics or diagnostics, because that's all for evolution. So if we have any alternate model, then we should see that are these numbers in the alternate model lower than these ones, because RMSE, May defines that the accuracy of finding the mean, so it's like shooting arrows and hitting bullseye. If it's 0, then obviously if you can find here lower numbers, then it means that you have better tendency to find the middle. RMSE is the accuracy of this, which means that what is the standard deviation of the result. So if also we can narrow it down, then it's also better. So we have to look for smaller numbers here. So if you just have one estimation, that we can't consider that this one is good or not, because we have to compare it always to something else. Yeah. So that's all for today. And after that, we can use it on the seminar, because now we have data to play with, and it's much better than just using other data from the forward market, which we also consider.